Hi everybody, today we're looking at parallel and perpendicular lines. Specifically, two lines are parallel if they neither diverge nor converge. So if we look at our diagram, these two lines are converging at this point, and at this end of both lines the gap between them is getting bigger. They're diverging, converging. In this case, neither of these two red lines are parallel, mainly because, well, we can detect that if the slope of either line is different. So if we knew the slope of this line and the slope of that line, we could compare them. If they were the same, they would be parallel, but in this case they're clearly not the same, the slopes are different. In our second example here, the lines have been drawn to be parallel. The gap between them remains constant. The gradient of this line is the same as the gradient of this line. The lines do not converge nor diverge. And we say thus that these two lines are parallel. So, how do we work with parallel lines? Well, in this case, we're trying to find out, is y equals 2x plus 1 parallel to y equals 2x minus 1? Well, to find out if they're parallel, we just look at the gradient. We can ignore the y-intercept, that doesn't matter. As we can see with these parallel lines, the y-intercepts are different. That doesn't impact the fact that they're parallel or not. We just look at the gradient here and here. M1, the gradient of the first equation is 2, the gradient of the second equation is also 2, the two gradients are the same, therefore the lines are parallel. Problem 1 done. Problem 2. Is y equals 2x plus 1 parallel to x plus 2y equals 3? Well, this is a little bit different. Before we can get the gradient of the second equation, we need to rearrange it into slope-intercept form. So this is what I'll do here. The first equation, the gradient's quite easy. It's just 2. This is already in slope-intercept form. Here's the gradient over here. For equation 2 though, it's not in slope-intercept form, so we're going to rearrange it. And over here it's in slope-intercept form. And we can see now that the gradient of the second equation is actually negative a half. Now because negative a half is not the same as 2, these lines are not parallel. They will intersect at some point. Question 3. Find a line parallel to y equals 2x plus 1 that passes through this point. Well, the first thing we need to do is find out the gradient of this equation. The gradient of it is 2. The gradient of the equation that we're looking for, because it would be parallel, would also be 2. So m2 must also equal 2. Now we need to find a line that has a gradient of 2 and that passes through this point. As per earlier examples, substitute them all into slope-intercept form and find c. Y is 8, x is 2, m is also 2, plus c. 8 equals 4 plus 4. By inspection we can see that c is also 4. Once we know that c equals 4, we can write out the equation of the parallel line. Y equals 2x plus 4, now that we know c. Easy enough. Looking at the complementary property, perpendicular lines now. Perpendicular lines have the particular property that they meet at 90 degrees. Now, a feature of that is that the gradient of one line, if they are perpendicular, will always equal the opposite sign multiplied by the reciprocal of the gradient of the first line. Okay, sounds very complicated. In actual practice, it is not. So if we were trying to find out if y equals 2x plus 1 was perpendicular to this line over here, we would get the gradient of the first line, it's 2. We would get the gradient of the second line, it's negative a half. We'd look at the first one, we'd take the reciprocal of it, so 2 is equal to 2 over 1. To take the reciprocal of something, turn it upside down, that would give us a half. Change the sign of it, that would be negative a half. Are they both the same? Yes, they are. These two lines are perpendicular. Example 2. Is y equals 3 over 2 take 3 perpendicular to 3x plus 2y equals 4? Well, the gradient of the first equation is simply 3 over 2. That's easy enough. We could rearrange this into slope-intercept form to find the gradient of this equation, which I've done here, and we've discovered the gradient is negative 3 over 2. Now the question we have to ask ourselves is negative 3 over 2 the negative reciprocal of 3 over 2? Well, let's have a look at what that would be. If I flip this, it would be 2 over 3. If I change the sign, it would be negative 2 over 3. Negative 2 over 3 is not the same as 3 over 2, or negative 3 over 2. To be perpendicular, this would have had to have been negative 2 over 3. It is not. Therefore, they are not perpendicular. And we've made our little statement here. It is M1 is not the negative reciprocal of M2. Question 3. Find the perpendicular line to y equals 2x plus 1 that passes through 2, 8. Well, the first thing we would have to do is find the perpendicular gradient. M1 is equal to 2. We can write that as 2 over 1. Once we've done that, we could flip it. That'll give us a half, and then change the sign. That will be negative a half. We want the gradient of the second line, the new line, to be negative a half. Now we have our gradient and a point. Substitute it into slope-intercept form. Y equals negative a half x plus c. Put in x and y. X is 2, y is 8. 8 is equal to negative a half of 2. That'll be negative 1 plus some value. 9 take 1 is 8. So by inspection, c would be 9. Therefore, the perpendicular line is y equals negative a half x plus 9. And there you go. Parallel and perpendicular lines in a few moments or less. I hope that was helpful, everyone. Thank you.